Hey students, a couple questions as we were going through, in this case, assessment 3.3. So question was on number 18A. So let's take a look at that one. So 18A says, perform the following operations. Hey, gotta love America. Like I said in the short video I made for this one, everybody else in the world would never do this to themselves, but we do, so we love it. So just remember, you just have to kind of know all the conversion factors. So 1 gallon is 4 quarts, which the quart comes from quarter of a gallon. 1 quart is the same as 2 pints. 1 pint is 2 cups. So we have kind of a 2-to-1, 2-to-1, then a 4-to-1 ratio. So it's not really a place value system. So as you're writing your final answer, it says perform the following operations. 1 quart along with 1 cup minus 1 pint and 1 cup. So it's usually best to rewrite these in such a way that the larger ones are on the left, the smaller ones are on the right. So a cup is much smaller than a quart. It's much smaller than a gallon. I typically prefer to have place value bars set up for myself, but just realize that at the end, your final answer could just be 1 quart, 1 cup. You don't have to put something in for pints necessarily. And that's because if it's 1 pint, it is just 1 pint. You don't have to say 1 pint, 0 cups. Again, we don't have to do that because we're recording the place value as we write the answer out. So if you weren't recording place value and all you had was columns, then you would need to put something in that place. So this measurement system is not a true place value system. So once you label it with pints, there is no need to put all of the other components. This is not I mean, we really could do something like this with numbers, not that I think we necessarily should. I think it would make it more cumbersome. But if you think about it, if we were to write out 3 tens 5, we'd be very clear, right? This is the same as what you might write up as 35. And so when we get used to saying 35 or writing 3-5, we get used to what the 3 means in terms of place value. So we could write it in such a way that we'd say 3 tens 5, in which case, if I wrote 3 tens, I would not need to write a 0 ones afterwards. Okay, and that's because 3 tens would be the same thing as 30, so it would have the same meaning. Since we, in our number system, tend to write, let me grab my annotation tool here. Since we tend to write this type in place value format, we don't include the place value or the language for the place value as we go. So I think that's the difference between them. Over here, when you're doing measurement systems, especially in American measuring systems, then you actually say how much it is as you're doing it. So that makes it a little bit easier, perhaps. Okay, let's see here. What else do we have? We have MC14. Okay, let me jump over there. Let's see. MC. Oops, I gotta turn that off. I still got my little checker on instead of the clicker tool. There we go. Okay, let's see here. A first character claims that 2 minus 4 is equal to 0 because you can't have less than nothing. How do you respond? Oh, an interesting question. So 2 minus, so they're saying that it equals 0. And so this would be a great time for you to bring up, possibly, and this is up to you, how you would choose to, because it says, how do you respond? How would you respond? You might want to hint at the fact that, hey, down the road, we'll actually have a way of categorizing that. You might say, oh, this is like an IOU. Like you can give me the $2 and that takes care of $2 of the debt in a sense. But you still owe me $2. So we have to have a way of writing down that, you still owe me some money, that kind of thing. You could also say, when we're dealing with whole numbers, if we're dealing with only whole numbers, there is no solution for this problem in the whole numbers. But that doesn't mean there's no solution for this problem if we expand. And so depending on how comfortable you are with the student, I think your response might vary based on what you know about them and the level they're at. You're going to find some advanced students, and I'm not going to lie about that. You're going to find some. And when you encounter those, I was actually working with one this maybe a year into the pandemic. And the student was in 5th grade and had just completed 9th grade math. And so that student was struggling in classes because they They were just a voracious reader. They read everything they could about math. They learned things. They were doing algebra type techniques in the 3rd grade. So when they come to you with a question, it's not bad to say, hey, depending on where they're at. So when you respond, say, okay, for a student this student seems very advanced, here's my response for an advanced student. That's perfectly fine. You don't have to have a response for every type of student, but you can at least say, for this student, here's how I'd respond if they were showing signs. Hey, it seems like you're really getting this. Maybe I would give them a tip that would allow them to do more, especially when that ties into number 18, because it really does, right? The idea that we're short 1, and we could write it short 1 in such a way that we would kind of say, okay, once I get to 70, I have to kind of backtrack by 1 because I was short 1 on the other subtraction. But yeah, absolutely. This is awesome right here. If a student came up and said, hey, I've got an idea. I don't like the way you were doing it with the regroupings. Can I try it this way? Holy crap. Wow. That's pretty cool. That's pretty cool. You may want to show the student, make sure that they understand the more traditional way as well. There are times where this approach will be cumbersome. And if you wanted to show the student maybe a 4-digit minus a 3-digit with multiple regroupings, this student would have multiple short pieces, short a number of ones, short a number of tens, maybe even short hundreds. And then they'd have to do quite a bit of regrouping along the way. So to show at least another technique, if this method doesn't work out, I think is a really good approach. You don't want a student thinking there's just one way to do subtraction or really any operation, because there's not. Let's see, I asked you to do group work number 2. And so, yeah, this falls right into it. So these are basically 3 of the same type of questions. Question number 14, 18, and then the group work 2. Yeah. So as you're going, this is actually, to be perfectly honest, this is kind of the approach that is utilized if you're going to be doing mental math. Mental math, you can do your hundreds and hold the hundreds. Then you do the difference between the next one. In this case, it's -50, right? Oh, well, I owe you 50. I had 500. You can do that mentally pretty quickly. So as you're doing it, you don't have to think of crossing a number off, regrouping, which is cumbersome. And because that process of rewriting and regrouping starts from the right-hand side, you have to do all of it before you can start saying the number. In this approach, you could start saying the number right off the bat. It's close to 500. Ooh, but I got to drop it by 50. I'm at 450. Ooh, I got to drop it by 3, 447. I can get that much quicker with this approach. Okay. Now, again, when you're starting, it says discuss why you think this is not included. Why is this not included at the 1st grade level or maybe at the 2nd grade level when they're doing these problems? Why? Give a response to student who shows you this way of solving with subtraction. This is very similar to MC number 18. Okay. But yeah, I think it's good to ask them questions as you're doing these problems. Hey, walk me through what you're doing. And if they've got great ideas for place value, then please don't tell them they're wrong. This is a fantastic algorithm. All right, that about wraps it up. All right, off you go.